Hello friends, my name is Anika Saurabh Sonke. Now we are studying about hypothesis testing in probability theory and random processes. Hypothesis testing is a fundamental statistical method. It enables decision making under security. This process is a circular for making informed judgments about population parameters, forming the basis of various applications like signal detection and parameter estimation. It is a statistical method to use decisions about a population based on sample data. It involves setting up two opposing statements, the null hypothesis and the alternative hypothesis, and then use statistical tests to determine which one is better and supported by evidence. Defining hypothesis. First one, null hypothesis. H0. There is a default statement about a population parameter. It represents the status quo or no effect. This is a default statement of one proposing no effect or no difference, and it is assumed true until evidence suggests others. For example, a null hypothesis might be state that a new drug has no effect on disease. Another one example, xi approximately n 01. Alternative hypothesis h1. This contradicts the null hypothesis. It suggests a different effect or relationship. Alternative hypothesis means this contradicts the null hypothesis and suggests there is a significant effect or relationship. For example, the alternative hypothesis to the above would be that the new drug does, does have an effect. Example, x approximately n 1 and 1. Simple versus composite hypothesis. A simple hypothesis is a fully specifies the distribution. A composite hypothesis does not fully specify it, leaving more or some parameters unknown. This is a set of values for test statistic that would be lead to the rejection of the null hypothesis. If the calculated test statistic fails with this region, the null hypothesis is rejected. This is the probability of incorrectly rejecting the hypothesis when it is actually type 1 error. A common significance level is 0.5, meaning it 5% chance of rejecting or a true null hypothesis. Test statistics and critical region. Test statistic, a function of a sample data used for decision making. For example, the sample mean is used to testing the population mean. A value calculated from a sample data used to evaluate the null hypothesis. For instance, a sample mean can be used to test a claim about the population mean. Critical region, the set of values for the test statistic and that leads to rejection of the hypothesis. It is a set of values for the test statistic that would be lead to the rejection of the null hypothesis if the calculated test statistic fails within this region. The null hypothesis is rejected. Significance level A. This this is the probability of incorrectly rejecting the null hypothesis when it is true. Type 1 error. The probability is incorrected in rejecting the null hypothesis when it is actually true. A common significance level of level is 0.05. It meaning there is a 5% chance of a rejecting a true null hypothesis. Now we can see type 1 and type 2 errors in hypothesis. Type 1 error is denoted by A, means alpha, rejecting a 0 when it is a true or false and positive. P bracket में reject a 0 into a 0 is a true. It is a type 1 error A, rejecting the null hypothesis a 0 when it is actually true or false or positive. The probability of a type 1 error is denoted by A. Second type 2 error B means beta, failing to reject a 0 when it is a false negative value. P fail to the reject a 0 H1 is true is equal to beta, failing to reject null hypothesis a 0 when it is a false, meaning the alternative hypothesis H1 is a true or false negative. The probability of a type 2 is denoted by B beta. Power of test 1 minus beta. The probability of correctly rejecting the H0 when it is a true, false power is equal to P reject H0 H1 is true is equal to 1 minus B. The probability of correctly rejecting the null hypothesis when it is false. It represents the ability of test to detect true effect or difference. Composite hypothesis testing. Unknown parameters. This testing deals with unknown parameters under either H0 and H1. This type of testing deals with unknown parameters under the null hypothesis H0. Generalized likelihood ratio test GLRT. GLRT compares the likelihood of data under the null and alternative hypothesis. This ratio is maximum L is equal to bracket मध्ये theta x into H0 max L bracket मध्ये 0 theta into 1 x minus H1. Reject the null hypothesis to test the compare likelihood of the data under the hypothesis H0 and the alternative hypothesis. The ratio is given by A is equal to x is equal to L H0 into x L H1 into x. Decision rule. Reject H0 if it's greater than false below a determined threshold. This threshold is set by the desired significance level of A. The reject the null hypothesis is 0. If the test statistic falls below a predetermined threshold, which is typically set by the desired significance level A. Applications of hypothesis. Signal detection. Signal detection determines the presence of a signal amidst noise. Parameter estimation. Verify estimated parameter values in various models. Quality control. Ensure the manufactured products meet strict specification. Medical diagnosis. Assess the likelihood of disease given by the symptoms. Here's one example to solve the example. A coin is tossed 200 times and turn head 108 times. Test hypothesis that coin is unbiased at 5% level of a significance. Now we can solving the example by defining hypothesis. 5% 5% probability is 0.05. It means it is a null value. A coin is unbiased, meaning probability of getting head P is 0.05. Secondly, we test alternative hypothesis at 1. The coin is biased, meaning the probability of getting a head is not 0.5. Secondly, given information in the question is number of trails n is equal to 200 times. Observed number of success means heads, it is 108. Calculate the expected values. Expected probability of P under the H0 is equal to 0.5. Expected probability of a failure is Q under the H0 is equal to 1 minus P is equal to 1 minus 0.5 is equal to 0.5. Expected number of success is equal to N into P. It means is equal to 200 into 0.5 is equal to 100. Now fourth step is calculate the standard deviation. It means standard error of proportion. Standard deviation sigma is equal to under root n pq is equal to it. Put the values of under root n means 200, p means 0.5 and q means 0.5. We can take the values under root 200 into 0.5 into 0.5 is equal to under root 0.50 is equal to 7.07, approximately 7.07. Now fifth step is calculate the Z statistic. Calculate the Z statistic. The formula for Z statistic for the proportion is Z is equal to observed value in minus expected value upon standard deviation. Now put the values 108 minus 100 upon 7.07. It means 8 upon 7.07, approximately 1.13. Now compare the Z statistics with a critical value. For 5% level of a significance to tailored test, the critical Z values are approximately 1.96. Means it is a biased and expected for 5% level of a significance. The coin is unbiased. The calculated Z statistic 1.13 falls within the acceptance of region between minus 1.96 and 1.96 is the less the critical value. There is a null hypothesis that 0 is expected as 5% level of significance. This means it is not enough evidence to conclude that the coin is biased. It is considered as unbiased. In ACT, 20% of a random sample space of 900 schools boys had a certain slight physical defect in another city. B. 18.5% of a random sample space of 1600 schools boys had the same defect to the difference between the proportion significance. It means the given data is n1 is equal to 900, n2 is equal to 1600. P1 means probability 1 means 0.2. It takes from probability 20% into 20% is equal to 20 upon 100 is equal to 0.2. P2 0.85. P2 takes from 18.0.5 percent is equal to 18.5 upon 100 is equal to 0.8. Common value for proportion. This combined proportion for of defective from both sample, assuming the null hypothesis is true. P is equal to n1 of n1 p1 plus n2 p2 upon n1 plus n2. Now put the values. 900 into 0.2 bracket complete plus 1600 into 0.85 upon 900 plus 1600. It means the value of the total equation is 0.19. Now calculate the standard error difference between the two proportions. SE is equal to under root P1 P bracket मध्ये 1 minus P is equal to 1 upon N2 N1 plus 1 upon N2 into is equal to under root put the values 0.19 in minus 1 minus 0.19 1 upon 100 upon 100 plus 1 upon 900 plus 1 upon 1600. Now take the values from for probability. 0.19 into 0.81 bracket मध्ये 1 upon 900 plus 1 upon 1000. E2 is equal to 0.0017. E is equal to 0.04. Z, now we can test Z statistic. This measures the how many standard errors the observed difference in proportion is away from expected difference 0 under the null hypothesis. Z is equal to P1 minus P2 is upon E is equal to P1 value is 0.2 minus P2's value is 0.85. It means the total of 0.375. The conclusion. Based on the analysis, there is no statistically significant difference between the proportion of physical defects in A and a city B can be chosen significance level. Thank you.